conditions as those showers move in and out of the area, 80 to 82 degrees with easterly winds at 7 to 12 knots. Looking at our launch forecast chart here with our Lightning launch commit criteria, tracking no issues currently. We're green for weather, and we are expecting to remain green all the way through the countdown and into the launch window. Any questions?
Okay, I will appreciate that updated weather brief. We'll go ahead and check step. Standby 1. We'll go ahead and check step 323 complete. And GSO-LC on countdown 1, can you confirm pad clear zone implemented?
GSO pad clear zone established.
Roger that. We'll check 324 complete.
Hello guys. So this is the Antares NG-16 launch from Wallops, Virginia. Launch right now, targeted for like 5:55 p.m. somewhere around then. Might not be on here as much because it's my birthday today and me having dinner soon. But I'll come here and check on for a while, but I'll still have the stream up, so you guys can watch the launch if you want. So yeah, that's happening today. Launch is scheduled for 6:01 p.m. EDT.
And launch team, be advised, we'll be coming up on our poll for readiness to begin propellant loading operations in approximately 5 minutes.
LC, red team lead, countdown 1.
And red team lead is LC. Go ahead.
I can confirm that the red team has arrived at V50.
All right, copy that. Thanks, red team lead. We'll check step 319 complete. And launch team LC, countdown 1. At this time, I want to perform our poll for readiness to begin propellant loading operations. Mars site,
Mars site is go.
GSO,
GSO, go.
RSO,
RSO's go.
TD,
TD's go.
CMD,
CMD is go.
safety,
Safety is go.
prop lead,
Prop lead is go.
stage 1,
And stage 1's go.
GC,
GC is go.
ACE,
ACE is go.
LD.
LD is go.
We're going to begin propellant loading operations at T-minus 1 hour, 20 minutes. Check step 326, and that completes our Lowell's chill down checklist. And launch team countdown has resumed. Check step 327. TLM at DCOM, stop and restart telemetry archiving.
LC, TLM and work.
And site control, you go for steps 329 and 330. Arm and start the RP1 tank desk and hose retract. Verify when retract complete. Arm and start LO2 tank desk and hose retract. Verify when retract complete.
And site control copies.
LC, TLM, archiving restarted.
RP1 tank desk and hose retract started. And RP1 retract confirmed. LO2 tank desk and hose retract started. And LO2 retract confirmed.
And I copy all site control. We'll check 328, 329, and 330. And site control, command tell to pre-pull back position.
And command sent. Tells in motion.
And Marcel, wait for your call on step 332. And launch team, be advised, start a core low flow RP loading and low flow LO2 chill down will occur at T-minus 1 hour 16 minutes. That's in just about 45 seconds. Phase 2 dynamic limits will be active at that time.
And LC is Marstel tells configured for pre-pullback.
Copy that, Marcel. Check 332 complete.
LC prop lead, I can report the start of low flow RP loading and LO2 vehicle chill down has started.
Copy that, lead. We'll check 334, and lead, step 335, can report status of RP1 low flow and LO2 chill down rates.
Yeah, they are going to need adjustment today.
Okay, copy that. And lead your go to begin those adjustments when required.
And LC, this is prop lead. The flow rates have been adjusted. Step 336 is complete.
Okay, I copy that, lead. We'll check step 336 complete.
LC site control.
Yeah, go ahead, site control.
I'm going to be off net for a little bit.
Copy that, site control.
And LC prop 3, flow RP, high flow RP loading is verified. Step 337.
Okay, copy, lead. We have 337.
And LC, prop lead, high flow LO2 chill down, verified, SEP 338.
Okay, copy. Lead will check 338 complete. And launch team LC on countdown 1, approaching T-minus 1 hour, 5 minutes. At this time, I'd like to get a report of readiness for accumulator refill. GCE,
GCE's go.
EHS,
EHS is go.
Ops 1,
Ops 1 is go.
Prop 2,
And prop 2 is go.
Prop Lead.
Prop lead is go.
Okay, we're ready for refill. Prop Lead, you're going to proceed with the HSS accumulator refill procedure. You can perform that on anomaly 1 and report when complete.
Copy and work.
And launch team, we've just passed through T-minus 1 hour.
And LC, this is prop lead, HSS accumulator refill complete, step 340.
Okay, copy that, lead. We'll go ahead and check step 340 complete.
LC prop lead, low flow LO2 loading, verified, step 341.
Copy. We have step 341. And launch team passing through T-minus 55 minutes. At this time, launch vehicle and Cygnus are not reporting any issues with their systems. The range is looking at a potential boat fouler at this point, and we'll be expecting an updated status relatively shortly.
And this is Flight Control. Go ahead. Oh.
And LC prop lead, high flow LO2 loading, verified, step 342.
Copy. We have step 342.
LC safety, countdown 1.
Station calling LC.
Safety, momentarily stepping off comm.
Yep. Copy that, safety.
LC safety, countdown 1, back on comm.
And I copy safety. And launch team, we're passing T-minus 50 minutes.
And LC-GCE on countdown 1.
Go ahead, GC.
Yeah, we got another concern with the helium supply, so I'd like to get a group on anomaly. We're still in constraints, but we started a significant decrease again.
Okay, copy that, GCE. Let's see, let's go ahead and get over to Anomaly 1. If I can get safety, flight assurance, and GSO on Anomaly 1. And launch team, be advised, we're passing through T-minus 45 minutes. GNC-1, LC, countdown 1.
LC, GNC-1, go ahead.
Yeah, we're ready for the recommendation for our flight computer trajectory file for today's launch.
Yes, LC, we'd like to select trajectory file 1 for today's launch.
Okay, copy flight trajectory file number 1, check step 343, and ops 1. Step 344, you're go to upload flight computer trajectory file number 1.
LC ops 1, inputting flight trajectory number 1 to flight computer. Complete.
LC, GNC-1, trajectory file 1 confirmed in telemetry.
GNC-1, you're coming in very, very faint.
Sorry, LC, trajectory file 1 confirmed in telemetry.
Copy that. Thanks, GNC-1. We'll check 345 complete.
And LC ops 1, ground to vehicle comm is nominal.
Roger that, ops 1. We'll check 346 complete. And ops 1, step 347, verify orb nav settings.
In work. And orb nav settings verified.
Copy that, ops 1. Check 347. And ops 1, you go to initialize nav position.
Orb nav position sent.
And LC, this is prop lead. Cold helium bottle submerged confirmed. Step 353.
Copy prop lead. We have 353.
LC, GNC-1, telemetry verified for orb nav.
Roger that, GNC-1. Check 349 complete. And I want to get a report of readiness for GC align. GNC-1.
GNC-1 is go.
Ops 1.
Ops 1 is go.
Elect 1.
Elect 1 is go.
Okay, we're ready for gyro compass align. And ops 1, step 351, mode orb nav to GC align.
LC ops 1, moding orb nav to GC align on my mark. 3, 2, 1, mark. 21, 18, 19.
And I copy ops 1. We'll check 351. And launch team passing through T-minus 40 minutes. And TLM step 355, configure launch vehicle decom source to open loop.
LC TLM in work.
NLC, prop lead, start of cold helium bottle charging.
Copy that. Lead, we'll check 354. PMLC on countdown 1.
Go for PM.
You'll go for step 357, reactivate radar sites and reinitiate C-band transponder interrogation.
In work.
LC TLM. LV decom switch to open loop. IRIG is 21, 21, 35.
And I copy TLM.
LC TLM. LV open loop telemetry being received and nominal.
Roger that. We'll check 356 complete.
LC, this is PM on countdown 1.
Go ahead, PM.
Radars 3, 5, and 18 are active. Range is holding beacon and all radar sites.
And I copy all PM. We'll check 357 and 358.
LC GNC1, step 352, orb nav telemetry verified.
And GNC1, I copy that. We can check 352 complete. Okay, launch team, we're going to go ahead and proceed into our local launch enable at this time. Ops 1, you go for step 359. Enable your local launch enable button to failsafe panel and verify indicator illuminated.
LC Ops 1, launch enabled and illuminated.
And GSO, you go to enable your local launch enable button and verify indicator illuminated.
GSO launch enable and illuminated.
And launch, you want to verify RCC enable abort buttons are enabled and illuminated. PM?
Enabled and illuminated.
RSO?
Enabled and illuminated.
FSO?
Enabled and illuminated.
TD?
Enabled and illuminated.
Copy that. Check 361 complete.
Global launch enable verified.
Roger that, Ops 1.
Launch enable verified.
Copy that, Elect 1. And Ops 1, you can stop sending ECU commands.
ECU commands halted.
And we'll check step 364. And Launch Team LC, be advised we are still working a couple of issues here. Range is continuing to monitor and to intercept with a potential boat fouler. We're also taking a look at our helium pressure, source pressure again, and that discussion's occurring as well. And Launch Team LC on countdown. Be advised we're coming up on T-minus 30 minutes. We did just receive a report from the range that the boat fouler has cleared, and so the range is currently working, no issues. We are continuing to take a look at our helium source pressure, and we'll continue to keep updates on that. At this time, I want to poll for final FTS power on and arm command test. Safety?
Safety is go.
And FSO?
FSO is go.
Ops 1?
Ops 1 is go.
Elect 2?
Elect 2 is go.
Okay, we'll go for final FTS power on and arm command test. FSO, bring up command transmitter with check channel on.
FSO and work. LC FSO.
Systems on the Antares rocket. And once Cygnus separates from the Antares rocket today and reaches its preliminary orbit, controls of the vehicle will be handed over to teams at Northrop Grumman's Mission Control Center in Dulles, Virginia. Teams there are being led by Mission Director Teresa Spinelli. And back in the International Space Station Flight Control Room in Houston, Texas, flight control teams are being led by Flight Director Greg.
The live stream is on, so I'll leave this going.
Our go for launch today at 5:01 and 5 seconds p.m. Central Time, 6:01 and 5 seconds p.m. Eastern Time. And joining us for today's launch broadcast from Northrop Grumman is Antares System Engineering Program Manager Christina Halona, and she'll be walking us through some of the features and milestones for today's launch. Christina, the launch was moved to the back of the launch window today. Can you explain what the teams detected on the ground and how it was resolved?
Hi, Courtney. Sure. So during our pre-launch checkouts, we detected an anomalous reading at the pad. So our Mid-Atlantic Range Spaceport and Northrop Grumman teams had to troubleshoot the issue out at the pad, which actually required our teams to physically inspect the pad. So after we had previously already cleared out of the pad for safety issues, obviously, so we had to get back out there and check out and make sure everything was up and running and everything looked good. And so that actually took a little bit longer than expected. So it took us to the tail end of our launch window. So everything looked good, and we're ready to go for launch.
HS1 is go.
Okay, we're ready.
Yes, and we're looking live now at the Antares rocket, standing ready to launch a Cygnus cargo spacecraft carrying more than 8,200 pounds of research, crew supplies, and hardware to the International Space Station. Christina, can you tell us more about this Antares 230 Plus rocket's capabilities?
Sure. So the Antares 230 Plus vehicle provides substantial payload performance into a variety of low inclination, low Earth and Sun synchronous orbits and interplanetary trajectories. So our Antares has actually been upgraded, our stage 1 core, which has a lighter composite structure and an optimized second stage motor. The upgraded stage 1 core allows the Antares engines to perform at full thrust throughout most of the first stage profile. The 230 Plus vehicle also has a cargo mass flexibility in which the Cygnus mass can be defined no later than 24 hours prior to launch. The Antares 230 Plus vehicle also has the ability to perform late load operations by the unique pop-top fairing as the nose of the vehicle is able to remove for the late cargo load.
And opening valve 8021 on my mark, 3, 2.
And the vehicle rolled out to the pad Friday, August 6th. It was then rotated horizontal for some late cargo, like you're saying now, and then it was returned to its vertical position where it sits now yesterday. So, Christina, can you walk us through the cargo late loading process and late load capabilities?
You can resume your...
Yeah, sure. So as I mentioned before, one of the unique features of the Antares 230 Plus vehicle is that there is the ability to do a late cargo load 24 hours before launch. The vehicle has a pop-top fairing where the nose of the rocket is able to be removed. Northrop Grumman has also built new specialized ground support equipment that allows us to take the vehicle from vertical, like you see it out the pad, and take it back horizontal, which we did previously, actually last night. So this allows us to drive what we call a mobile clean room right up to the tip of the fairing, where we are able to remove the pop-top fairing and load time-sensitive research experiments and other perishable items that NASA needs to provide 24 hours before launch. And so with all this talk about cargo, the Antares vehicle is carrying approximately a little over 8,200 pounds of cargo to the space station aboard the Cygnus spacecraft today, which is actually our largest resupply to date. So we're very excited about that. And we at Northrop Grumman, we're really proud of our Antares 230 Plus rocket and the Cygnus spacecraft, and we're dedicated to continue to providing the best value to our customer in support of their critical missions.
And just going off of that, Antares and Cygnus have now been part of the chain of resupply for the International Space Station for several years now. How crucial has Northrop Grumman's role been in contributing to that?
So Northrop Grumman has played a critical role in keeping the International Space Station operational since 2013. And this was apparent with NASA awarding Northrop Grumman 2 additional commercial resupply missions to continue to deliver cargo such as food, hardware, science experiments, and other necessities. And Cygnus is unique in its ability to carry away large amounts of pressurized cargo, a critical function for NASA and the crew aboard the ISS. With these additional awarded flights to the orbiting laboratory, Northrop Grumman will provide services to both NASA and our commercial partners to continue to use Cygnus not as just a cargo delivery and disposable vehicle, but also as a platform for science and technology research and development opportunities. And since 2013, Northrop Grumman has been a trusted and reliable partner to NASA, and we look forward to this continued partnership into the future.
And now teams have been running through some pre-launch milestones today, and they'll continue to run through those through launch. Can you tell us a little bit more about the fueling process?
Yeah, so I'll just go through the entire ascent, actually. So when Antares, we'll have a stage 1 ignition at T0, and we'll lift off shortly after. The main engines will burn off for approximately 200 seconds, and that will get us to main engine cutoff, which we call MECO. And then once we get to MECO, we'll go into a short coast right before we separate stage 1 from stage 2, which we call the upper stack portion of Antares. We'll continue to coast a little bit longer, about 30 seconds before fairing separation, and then we'll have an internal separation where the stage 2 flies out of the external upper stack. So once stage 2 is completed of the upper stack, the stage 2 ignites for a 2.5-minute burn that puts Cygnus real close to their orbit. And then Cygnus will coast a little bit to ensure everything is stable. And then Cygnus will be released into the desired orbit. So after Cygnus is released, it will go through comm checks, and then about an hour or so after we separate, Cygnus will release its solar arrays and be on its way to the International Space Station. And I believe you at NASA, you guys also showed the solar array deployment sometime, so you guys all might get to see that again later. But in summary, it takes approximately Cygnus 9 minutes to get to orbit, so it takes some time, but it is pretty fast.
Well, Christina, we're looking forward to welcoming Cygnus aboard the International Space Station, and of course, we'll have you back to join us after launch as well. So do you have any final words before launch today?
No, I don't. Go Antares and go Cygnus.
All right, thanks, Christina. You just heard from Northrop Grumman, our Antares System Engineering Program Manager, Christina Halona. Stay tuned after launch for a post-launch interview with Christina again and an interview with Jeff Arend, NASA's Systems Engineering Integration Office Manager. Again, mostly sunny skies for launch today back at the Mid-Atlantic Regional Spaceport at NASA's Wallops Flight Facility in Virginia, and temperatures are now about 83 degrees Fahrenheit at the pad. Again, going up on Cygnus today is more than 8,200 pounds of research crew supplies and hardware, which is Cygnus's heaviest load to date. Within that cargo is 3,078 pounds of crew supplies, 2,346 pounds of science investigations, 33 pounds of spacewalk equipment, 2,286 pounds of vehicle hardware, and 98 pounds of computer resources. Cygnus will also carry a new mounting bracket that astronauts will attach to the port side of the station's backbone truss during a spacewalk planned for later this month. The mounting bracket will enable the installation of the next pair of iROSA solar arrays at a later date. Now let's take a quick look at some of the scientific investigations traveling to the space station on this mission. And of course, it's always exciting for the crew to receive new experiments, but they'll also have some extra goodies arriving. Also flying on Cygnus today are some treats for the crew, just to name a few. The crew will be receiving apples, tomatoes, kiwis, pizza kits, and cheese assortments.
CMD. Yeah, you're good. Transfer Cygnus to launch mode. In work. Copy, in work.
Coming up on 15 minutes from launch today, all systems are still on track for an on-time launch today at 5:01 and 5 seconds p.m. Central Time, 6:01 and 5 seconds p.m. Eastern Time.
Can you provide status of trajectory file for launch operation?
LC GNC1, trajectory file does not require an update.
Copy that. We'll check 403. And Ops 1 404 not required today, 405 not required.
Copy, LC.
And Core 1 LC, countdown 1.
Yeah, LC, I've got step 394 for you. Fuel level does not require adjustment.
Roger that. Prop 2, step 395, arm OCCS for no adjustment to fuel level.
And OCCS AC/DC armed.
AC/DC confirmed.
Copy. Check 395, 396.
And OCCS configured for no adjustment to fuel level.
Check 397. Admin be advised, step 398 not required. Step 399 not required. And launch team, we're coming up on T-minus 14 minutes. We'll be polling for our final countdown in about a minute and a half.
Just to highlight some upcoming milestones, about 12 minutes from launch, flight controllers will conduct a poll to proceed with the final launch countdown. And about 5 minutes from launch, the vehicle will switch to internal power. Then just about 3 minutes and 30 seconds before launch, auto sequence handoff for terminal countdown will be initiated, and that will mark the time the computers take over for the final milestones before launch.
054, 055, 056.
LC at CMD on countdown 1.
Flight pressure.
Stand by, CMD.
And so those constraints will be waived from 4,000 to 3,850.
And go ahead, CMD.
Yeah, CMD. Cygnus is in launch mode at nominal.
Roger that. We'll check 407 complete. And launch team LC on countdown 1 with poll to proceed with final countdown. GSO.
GSO, go.
RSL.
RSOs go.
TD.
TDs go.
Prop lead.
Prop leads go.
Stage 1.
Stand by, LC.
MES1.
MES1 go.
GCE.
GCs go. Sorry.
ACE.
Aces go.
Mars.
Mars is go.
CMD.
CMD is go.
And LD.
I'd like to hear from Stage 1 first.
Yep,
Stage
stand
1
by.
is go.
Stage 1 is go.
LD is go.
NG.
Northrop Grumman is proud to honor accomplished NASA astronaut and the first Asian American in space, Ellison Onizuka. In our current challenging times, we reflect on Ellison's inspirational words. The people that make the world run, whose names will go down in the history books, are not the cynics, the critics, or the armchair quarterbacks. They are the adventurists, the explorers, and the doers of the world. When they see a wrong or a problem, they do something about it. When they see a vacant place in our knowledge, they work to fill the void. And today, we will do just that. Aloha to the SS Ellison Onizuka. Northrop Grumman is go for launch.
And I copy. We're go to proceed with final countdown. Check 407. Fly high, Ethan. Ops 2, step 408. You go to start engine evacuation.
LC Ops 2, engine evacuation started.
And you just heard the poll to proceed with the final countdown to launch, and all teams are polling a go. And, of course, a tribute to Ellison Onizuka, who this Cygnus spacecraft is dedicated after. Now coming up on 10 minutes away from launch, and everything is still proceeding smoothly for launch at 5:01 and 5 seconds p.m. Central Time, 6:01 and 5 seconds p.m. Eastern Time.
Passing T-minus 10 minutes.
Once we get to that launch time today, the first thing that will occur is the Stage 1 ignition, and you'll see liftoff just a few seconds after that, and those main two engines will burn for about 3 minutes and 18 seconds before cutting off, and Stage 1 will separate. Cygnus will coast for a bit until fairing separation, when the external cover that protects the spacecraft during launch will separate. The interstage adapter that connects the first and second stages will separate at about 4 minutes into flight, and then Stage 2 ignition, which is that solid rocket fuel that will burn for 2 minutes and 45 seconds. Once the second stage burns out, we'll be listening for a call of orbital insertion at 6 minutes and 52 seconds after launch. The vehicle will coast for 2 minutes before Cygnus separation at 9 minutes and 9 seconds after liftoff. And at the time of launch, the International Space Station will be flying 260 statute miles over the southern Indian Ocean.
ACS VDMs enabled, voltage nominal, ODM commands clear.
And a copy all, check 410 and check 411. Step 412 not required for today's operation.
Now just about 8 minutes and 30 seconds to launch. Again, that next milestone we'll hear will be for the vehicle to be turned to internal power at 5 minutes out.
And we're at T-minus 8 minutes.
LC site control, GN2 conditioning initiated.
And I copy GN2 conditioning initiated. Passing T-minus 7 minutes.
Now inside 7 minutes, you've been hearing teams running through some of these final milestones, and the internal power has been activated. Again, it'll be switched over to internal power at the 5-minute mark.
Okay, copy. And when you come back up in 4 minutes, will you be ready to roll?
Hope so. Stand by.
Okay, copy that.
LC prop lead, VTSO activation verified.
Roger that. Check 414, Ops 2, initialize ground ordnance power supplies.
LC Ops 2, ground ordnance power supplies initialized.
Ground ordnance power supplies nominal.
Check 415 and 416.
LC site control, F-Bay ECS transfer to GN2 confirmed.
Copy that, site control. Check 417.
T-minus 5 minutes. Ops 2, you're go to initiate engine priming.
Engine priming started.
Ops 1, transfer avionics to internal power.
LC Ops 1, All internal power on. Standby 5. And all external power off.
Internal power is nominal.
Ops 1, open FTS Umbi loop.
FTS Umbi loop open and green.
You just heard those calls to initiate internal power for the vehicle, so internal power is now on, and all systems are still proceeding on track for launch just 4 minutes from now.
3, 2, 1, mark. Arm command sent.
SNAs, ODMs, all armed.
Copy that.
T-minus 4 minutes.
LCMES1, step 426, priming verif.
Copy that. Check 426 complete. And TD, I'll wait for your report on range status.
LCTD, we are green.
Copy, range green. Check 425. Step 427, not required. Phase 3 dynamic limits will be active at T-minus 3 minutes.
FC commanded to flight mode.
Check 429.
Auto sequence start.
LCTD, we're green for all systems. Green for all systems.
ODM bus voltages and currents nominal.
Copy like one, and I copy. TD, we'll check 430, 431. GNC 1, verify ready for nav mode.
LC, GNC 1, orb nav ready for nav.
Ops 2, step 433, switch to nav.
LC Ops 2, orb nav, switch to navigate.
2 minutes and 30 seconds to launch, still counting down to that exact liftoff time at 5:01 and 5 seconds p.m. Central Time, 6:01 and 5 seconds p.m. Eastern Time. Tanks will be pressurized at about the T-minus 40 seconds until liftoff, and we'll be counting down to liftoff from there.
T-minus 2 minutes. Mark. Passing through T-minus 1 minute, 30 seconds. T-minus 1 minute. Mark.
Forty seconds until liftoff.
T-minus 30 seconds. Mark. T-minus 10. 5, 4, 3, 2, 1. There's engine ignition.
Main engine start. And we have liftoff of Antares for the NG-16 mission in the Wallace Flight Facility. Engines at 100%. Attitude nominal.
The SS Ellison Onizuka now on its way to the International Space Station to deliver more than 8,200 pounds of cargo. Good first stage performance so far.
AV and power subsystems are nominal. NG-16, all systems are nominal. Engine's at 100%. Duration of stage 1 burn is approximately 3 minutes and 18 seconds, currently at 65 seconds. Passing through 40,000 feet, passing max Q.
First stage now passing through the area of maximum dynamic pressure. Again, this first stage will burn for about 3 minutes and 18 seconds until main engine cutoff.
All subsystems continue to perform as expected, passing 70,000 feet. Mission time plus 110 seconds. Engines continue at 100.
So guys, sorry I missed the launch. It's busy, but it looks like the launch is nominal.
Attitude nominal. All GNC performance as expected. And Terry's performance continues nominal. Throttle down to 80%.
Throttling down 3 minutes into flight, main engine cutoff coming soon.
Throttle down to 55%. All systems nominal. Stage 1 MECO.
We have main engine cutoff and Terry's entering into a co-stage, standing by for stage 1 separation.
Then stage 2 ignition.
Stage 1 separation confirmed.
And Terry's is in coast phase, attitude nominal. Fairing separation.
Fairing separation confirmed.
And we have stage 2 ignition. Stage 2 will burn for roughly 2 minutes and 30 seconds. All systems continue nominal.
Stage 2 ignition is confirmed. Stage 2 is that solid rocket fuel that will burn for about 2 minutes and 45 seconds. Burnout will come at 6 minutes and 52 seconds into the flight today. And as we lose sight of the vehicle, we're now switching to animation.
4.5 kilometers per second. Altitude approaching 140 kilometers.
Now 5 minutes into flight, everything proceeding smoothly.
Stage 2 burn continues, all systems nominal. Approaching 150 kilometers in altitude. Stage 2, all systems are nominal. Approximately 1 minute to Stage 2 burnout. Altitude 170 kilometers. All systems continue to perform as expected. Approximately 30 seconds to Stage 2 burnout. Stage 2 burnout. All systems nominal.
And Stage 2 burnout is confirmed.
Antares will coast for approximately 2 minutes till spacecraft separation. Antares is in orbit. Altitude nearly 180 kilometers. Attitude nominal. Attitude nominal. Antares continues to orient and prepare for spacecraft separation in a little more than 1 minute. All subsystems nominal. Altitude 179 kilometers. Roughly 30 seconds to spacecraft separation.
Standing by for spacecraft separation.
Attitude nominal. And we have spacecraft separation. Go Cygnus.
Spacecraft separation confirmed, and Cygnus has separated from the second stage. And Northrop Grumman teams now celebrating the confirmation of spacecraft separation.
LC with that, flyout calls are completed.
Copy that, Ace. Okay, launch team, let's maintain protocol on station here. We're in our post-launch checklist. Prop 1's already given us step 444. Pulse purging is in progress. And GNC 1, I'll wait for your call on status for step 445. State vector.
LC GNC 1 in work.
And I copy in work. And site control, step 446, you can remove aft bay GN2 flow and reconfigure ECS to post-launch.
In work.
Core 1 LC, step 447, direct personnel to power off the MS ground equipment and report when complete.
Yeah, copy that, LC. We'll get that in work once personnel can return to the LEV.
Yep, copy that. And, right, same thing for 448. Understood.
With that confirmation of successful orbital insertion, Cygnus is now on its way to the International Space Station, where it will arrive in 2 days on Thursday, August 12th, to deliver more than 8,200 pounds of cargo. Back with us now from Northrop Grumman is Antares System Engineering Program Manager Christina Halona. Christina, what will the Northrop Grumman teams in Dulles do here on the ground between now until Cygnus arrives to the space station?
Yeah, so the Northrop Grumman teams in Dulles has quite a few things that they'll be doing. So they operate the Cygnus spacecraft basically now that we have been released from Antares rocket. So from separation from separation to destructive reentry at the end of the mission, the Dulles team performs various operations, including, initial vehicle configuration following insertion orbit, which include priming the propulsion system. They'll also have the solar array deployment as well that will be happening here with you soon here in about an hour, hour and a half. And then they'll also be planning and executing various maneuvers to change Cygnus's orbit to rendezvous to the ISS. So that'll be continually changing throughout their maneuvers to get to the laboratory. And then there's also vehicle system checkout. So we continue to monitor the spacecraft as well to make sure it's healthy and everything is looking great on the spacecraft. And then at the end, they'll finally perform vehicle configurations to perform the final rendezvous as they arrive to the ISS.
And looking forward to Cygnus departure in November, Cygnus will perform some secondary operations. Can you go over some of those?
Yeah, so Cygnus actually has 2 secondary mission objectives for this NG-16 mission. After it departs from the International Space Station, there's one that is a passive payload from NASA called CREPI, and it stands for Kentucky Reentry Probe Experiment, and the payload will be loaded into the pressurized volume of the Cygnus with the disposable cargo items. And then the other payload is PURPLE, which is short for Prototype Infrared Payload. Purple is a Northrop Grumman built payload and will be tested and calibrated on while Cygnus is burst to the ISS. And the Purple payload actually requires 23 days of operations following departure to perform data collections and data downlinks. So we still have those 2 missions to complete after we are unberthed from the ISS. So Cygnus has a lot of work of it ahead until here in November.
Thanks, Christina. Again, we are looking forward to welcoming Cygnus to the International Space Station, and thanks again for joining us.
Of course, thank you.
And now joining us is NASA Systems Engineering Integration Office Manager Jeff Arend. Jeff, how important are these resupply missions in terms of the continuing resupply of this station and the science they deliver to the crew on board?
So I guess first off, hi, Courtney. But these commercial resupply missions are very important to continue the advancing science on board the station. Over 3,000 experiments have been conducted during the station's lifetime, which we're now coming up on 21 years of continuous human presence. On this flight, Cygnus is packed with more than 3,700 kilos of supplies, research, technology demonstrations, and hardware. In the tech demo category, we're really excited to add the 4-bed CO2 scrubber. It's an upgraded version of Seadra, which is our primary CO2 removal system on board. And for hardware upgrades, we're equally excited to be flying the 3rd IROSA mod kit, which will enable a future solar array upgrade in the future.
All right, and